All right, today we're going to talk about classification of matter. What is matter and the different types of matter. Okay, so what is matter? Matter is really just anything that has mass and takes up space. So we're going to go through the three forms of matter: solid, liquid, and gas, which you probably have gone through from junior high or even elementary school. And then two types: pure and impure substances, also known as mixtures. All right, so solids, how we define a solid, it's a definite, which means it can't change, it's unchanging, an unchanging shape and volume. So if you're like sitting in a chair right now, good for it being a solid because it's not going to change its shape or its volume, or else you'd probably fall off of it. As opposed to liquids, their shape can change based on the container you pour your liquid in, but the volume is unchanging. So if you poured 100 milliliters of water in a cup, it's going to look like the cup shape. You pour that 100 milliliters into a bowl, it's going to take on the shape of the bowl. You still have 100 milliliters, it's just the shape changed. Gases have a changing shape and changing volume. So, like for example, if culinary classes are making cookies, you can smell like the cookies smell right when they start baking near the classroom, but eventually that smell spreads out because again, that's the gas molecules changing shape and volume. So solids, if you look here, don't have a lot of space in between the particles. Liquids, a little more space between the particles. Gas, a lot of space between the particles. So that's what kind of constitutes the different shapes and volumes that we see between the three types of matter. All right, pure substances. Okay, so they only contain one type of matter, and they cannot be physically separated. So we're going to see here, pure substances are chemically combined. So they're either sharing or there's a sharing or donation of electrons that keep these substances together. So whenever you see elements or compounds, these are pure substances. So these are the two types of pure substances, elements and compounds. Okay, so get to be a little more specific here. Elements, they're the simplest of pure substances because they're only made of one type of atom. So we're going to kind of see later on what is made up of an atom. But yeah, an element contains only one type of atom. So the carbon element is only made out of carbon atoms. They're represented by symbols found in the periodic table. So for example, capital C is carbon, capital O oxygen. We have nitrogen here. Au is gold, Ne is neon, and Pb is lead. So whenever you only see one capital letter, that is an element. If you see capital letter in a lowercase, that is also an element. But key thing, one capital letter. Compounds are two or more elements chemically combined. So again, how they're chemically combined, that means that there's electrons either being transferred between elements or being shared between elements. So that's what we mean by chemically combined. They cannot be separated by physical means. Okay, so you could not karate chop with your hand water and separate the hydrogen oxygen molecules. You would need to run some sort of chemical reaction to separate the hydrogen from the oxygen. The compounds are also represented by symbols. To differentiate between elements and compounds, compounds have two or more capital letters in their formula. So here, H2O, okay, so two capital letters. Capital N, little a, capital C, little L. This is salt, NaCl, sodium chloride. So we have two capital letters here. Capital Cu, copper, with capital S, sulfur, capital O, oxygen, four of those. So we have two or more capital letters here. We got three. So that is a compound. Okay, so elements have just one capital letter present. Compounds have two or more capital letters present. So that's a good way to differentiate between the two. All right, so now we get into mixtures, so impure substances. So mixtures or impure substances are physical combinations of two or more substances. So it's not a transfer of electrons or sharing of electrons. They're just physically kind of just next to each other. So yes, they can be separated by physical means. So we'll get into different physical separation techniques later on. They contain substances other than elements and compounds in a pure sense. All right, so there's two types of mixtures: homogeneous mixtures. So that means that they're well mixed and they appear as if they're one substance. Okay, so kind of think of the prefix homo means same. Okay, so it looks the same throughout. So you cannot easily pick out the parts. So these are also known as solutions. So like salt water, when you dissolve salt in water, if you stir it really well, you won't be able to like actually with your like hands pick out the salt from the water. Same thing with Kool-Aid, a Kool-Aid mix, powder and water. Again, you stir it really well, it's going to just look like colored water. Same thing with lemonade. So a homogeneous mixture is also known as a solution. It looks the same throughout. You can't, it's going to look the same throughout. So like the first taste of lemonade is going to taste the same as the end of your lemonade. There's no kind of difference between that whole mixture there. Heterogeneous mixture means you can easily pick the parts out. Again, hetero, the prefix means different throughout or different, so it does not appear the same throughout. It looks different throughout. So you can see distinct different parts within this mixture. So salsa, you can find like the tomato chunks, the onion chunks, the cilantro chunks. You can pick out cilantro if you don't eat it, if you don't like it. Chex Mix, you can pick out your favorite parts of Chex Mix at a party and then leave the rest for other people to eat. Sandy water, you can see the sand sink to the bottom of the water, go above the sand. And Italian salad dressing, you can see the oil and water or vinegar separate from each other. So heterogeneous mixtures, they look different throughout, or they do not look the same throughout. Here's just a nice little flow chart, a yes or no. If you're looking at some matter, you can look at this more on your own if you want to pause this, but it's just a nice way to kind of figure out if something you're working with is what type of matter it is. Okay, so now we're going to get to physical properties of matter. Physical properties of matter is a description of matter without actually changing what it is. So you're not changing the actual chemical makeup of it. You're just kind of changing, or it's a property physically what it would look like or smell like. So using your five senses. So the color of something, okay, so the color of the computer you're looking at right now or your phone. The smell that is around you right now. The hardness, so like we would use that for in a mortar and pestle in the chem lab. How if it was really like something was really crunchy, hard to kind of crush in a mortar and pestle, or was something really kind of powdery and soft to crush. The density of something, which is just its mass over its volume. Boiling point, so you're just stating, okay, at 100 degrees Celsius, water will boil. And then melting point, what temperature does your substance melt or freeze at? So when you melt or freeze or boil or condense a substance, you're not changing its chemical makeup, you're just changing what phase of matter it is, which is a physical property. Right, chemical properties is a description of matter when it's changing. So whether something reacts with a certain chemical, so key, if you ever see the word react, that's a key sign that you're working with a chemical property. Will something catch on fire or something flammable? That is another chemical property. So anything with a chemical reaction or something, catching on fire, those are some key chemical properties. So you're actually going to change what your substance is. So after you're like here, if you're burning a piece of paper, you can't take the ashes of your paper and make it back into normal paper. You have it's a chemical property that you have permanently changed your substance. All right, last thing, intensive and extensive properties. So another way to describe matter. An intensive property does not depend on the amount of substance you have. So the color of, let's say, coffee, if you had a drop of coffee, it's still going to look the same color as like half a cup of coffee or a full cup of coffee. The boiling point of water is going to be the same regardless of how much you have of it. I mean, the amount of time it takes to get to a boil will matter on how much you have, but the actual boiling point itself of 100 degrees Celsius would not change. And then the smell of something is an intensive property. Extensive properties does depend on the amount of substance, so the property is not always the same based on how much you have. So obviously mass, if you have a little of something, you're going to have a small amount of mass. If you have a lot more of something, you're going to have a bigger mass. Same thing with volume. If you have a little bit of something, you're going to have a smaller volume. More of that substance, you're going to have a bigger volume. Same thing with weight. So extensive, it does depend. Intensive, it does not depend. All right, that is it. Thank you.